Fantastic. Okay, well, thank you very much, everybody, for joining week 22 of the Tinkerbell Contributors Meeting. I'm going to be hosting this week's call. As mentioned, it is recorded, and all of these calls end up recorded on the Tinkerbell YouTube. If there are new faces and you wish to introduce yourself, then please do so now. Okay, cool.
Hi.
Oh, hello.
Sorry. I just was on the mute. I don't know whether you can see.
I can see you, yeah.
Okay. So yeah, I'm Raj Darwatkar. I have joined the Ben Rockwood yesterday, and this will be my first meeting.
Oh, fantastic. Well, welcome. Excellent. Well, thank you so much for joining. If you do have any questions, please feel free to raise your hand and ask away.
Okay, thank you.
Excellent.
Yeah,
one other thing. Oh.
Yep, I'm Nahum Shalman, and I'm also on Ben Rockwood's team. I joined last week.
Excellent. Cool. Well, thank you very much. And it's a pleasure to see more and more people joining these calls. As mentioned, if you do have any questions or if there's anything we can delve into in more detail, then please do raise your hand and we will do what we can to kind of answer your questions. One final thing is that we do have a code of conduct. Effectively, be nice to each other. This code of conduct follows pretty much kind of the Kubernetes 6 code of conduct. So we will kick this week's call off. I've added quite a lot of things to the agenda this week. So I'll kind of go through those. There's been kind of quite a lot of work over the last kind of couple of weeks. But I'm kind of kicking off with wrapping up a lot of the things that we set out to do in Q1. So a lot of the goals really in Q1 were kind of improving the developer experience, the user experience. So we've put in kind of quite a lot of work in modifications to things like the Tink CLI, making it a little bit more sane. A lot of work around documentation, a lot of work around actions, reusable actions with things like the artifact hub. We also now have a Vagrant box as well. So you can go to the Vagrant box on the HashiCorp website, where you will find a Tinkerbell Vagrant box, which has everything that you would need. So you can basically like one click and get everything that you need to get Tinkerbell up and running. Yeah, so we've kind of achieved more than we actually set out to do in Q1, which has been fantastic. It's been a lot of fun. And we're going to start looking at what our plans are for Q2 coming up in the near future. So thank you, everybody who's committed work, suggestions, PRs, issues. It's been fantastic so far. Was there a question, sorry? No, okay. Right then, so I'm going to kick off with some of the new things that we've added over the last kind of couple of weeks. First off, as part of a lot of the work that we were doing to improve the documentation around Tinkerbell, it kind of became obvious that it's great that a lot of kind of cloud providers provide things like cloud images. However, there is a lot of use case where those cloud images don't have kind of the necessary components that we may need. Good example is things like the Ubuntu focal image. So, we can grab these small lightweight images, turn them into something that we can use. However, they tend to run a specific kernel, either the KVM or the cloud kernel. That typically means a lot of functionality is actually missing from that kernel. So things like kexec or a lot of hardware drivers. Obviously not all cloud providers have these cloud images that we can make use of. So we started to look at researching what it would take for us to have a repo that produced our own cloud images, our own Tinkerbell images. We kind of took a bit of inspiration from Image Builder from the Kubernetes SIG. So they already provide a load of code for putting together Ubuntu images that have all of the necessary components for Kubernetes. So with that, and following on from the naming convention that we have kind of adopted, I'm just going to open this up and share a different window. So we now have a new repository called Crocodile, which is aptly named after the crocodile from Disney's Peter Pan. It even actually houses the crocodile when you actually run it. But the most important thing is that we have tried to make it as easy as possible for end users to build operating system images. The concept, or the key technologies behind this typically are HashiCorp Packer, Docker runtime, and mainly bash scripts. But effectively, the end user experience is that you can effectively clone this repo, do a Docker build, which will get all of those components into an image for you, followed by a Docker run. And that Docker run will give you the opportunity to build a variety of different operating systems. So at the moment, we've implemented Windows 10, Windows 2016, 2019, 2012, ESXi 6.5, 6.7, 7.0, and Ubuntu with Nixos coming soon. And I added Alma, which is the replacement CentOS, last night as well. So I think it'll build about 10 different operating systems at the moment. And it automates the entire process. So at the moment, you get this menu, you can select which operating system you want, and it will get the ISOs, it will start up Packer, it will start QEMU, and it will automate the entire process to get you the basics of an operating system, and it will deposit that as a raw image. I can quickly kind of show you what that looks like. So let me find a window. 1 second. So I'm just going to share this window, make it a little bit bigger.
And I have a question.
Yes, ask away.
FreeBSD is coming too.
It's a good question. I've not actually looked. So I was going to go through the OS documentation in a second, but FreeBSD already provide a cloud image, which is a compressed image. It's in the XZ compression algorithm. Why did Clear not get rid of my password? Anyway, nobody saw that, apart from it's recorded. Yes, so we can convert from that image to something else that we can use. However, it might be nice to include this as an option in here as well. So we certainly can look at doing that.
Awesome. If I can help, I'll ping you and maybe
Sure,
I can do something there as well. Thank you very much.
So as mentioned, if we do a Docker build, I've already built this a number of times, but it effectively will take an Ubuntu image, it will install QEMU in there, it will install Packer, and it will set up the environment that we need. We're probably not going to upload this image to a hub, mainly because it's quite big. It's probably easier for people to just take the Docker file and build it locally. However, if people ask for it, maybe we will. I haven't decided yet. But once we've built that image, we can do a run. And as we can see here, it's started up the build environment. We can select an operating system. So I can select number 9, which is Windows 2016. And I'm running it in the wrong directory. What have I broken here? Yeah, well, we can see here when we kick it off, it will try and it'll retrieve the ISO that we need. It will start QEMU and it will do all of the steps needed in order to build that. If we cancel this, we can see locally, we pass through a Packer cache directory so that we don't need to download everything every time. So if we look in here, we can see there'll be a bunch of ISOs. These are the ISOs that it will retrieve when it needs to do a build. And there's also the images directory, which is the output. So we can see here, these are things that I've built recently. And these are basically compressed raw images. So they're quite small, which makes them very quick to deploy. So using kind of the image to disk action, the main bottleneck really is how much data we need to send over the network. So the smaller the images, the faster that we can actually deploy. If we look at these ESXi images, they're 340 meg, 330 meg or so. That typically means deployment time is in the realm of about 20 seconds or so to rebooting and actually starting up ESXi. Finally, we've tried to make it as modular as possible. So in configs directory, we can see these configs define how the builds actually take place. Packer's not too complicated. It does take a little bit to get your head around. But effectively, we're building things in the raw format. We run a number of different scripts against them in order to provision them. And then finally, we kind of compress the output. So we're going to try and add a lot more documentation around that to make this much easier for people to kind of take and build on. So as mentioned, we're going to keep our images as basic as possible. Ideally, we're just going to install Windows and do nothing else with it, apart from a default user, which will be the user Tinkerbell. We certainly don't want to get to the point where we're supporting like Windows 2016 with WordPress or Windows 2016 with MySQL, or kind of that is just unmaintainable. So here are the basics. Build on it as you will. Do with it as you will. We'll just keep the most basic images for you to actually consume and make use of. So that is Crocodile.
I have a question. How's it in terms of CPU architecture support? If I was to deploy this to Raspberry Pi, for example?
Yes. So at the moment, all of the images that it builds are x86. However, Packer will build ARM images. So we would need to add in an additional provisioner. Probably not easier looking at that one. If I look at the Ubuntu one, there's this builder section that I've highlighted here. We can have a builder that will make use of, because it's using QEMU, we can actually specify it to use things like QEMU-ARC64. So it will effectively emulate the ARM processor, and we can tell it to pull the ARM installer, and it'll effectively then build ARM images for us that we can then consume on Raspberry Pis.
These images, do you ship them to, or do you deploy them afterwards to the Nginx that is also running on the Tink stack?
Yes, I can show you kind of how we deploy them. I will just pop to my Tinky server. So if we look here, I'll make this a little bit bigger as well. So this is my local deployment environment. We can see here that I've got a bunch of images that I've put. So they're effectively in the web roots directory inside the Tinkerbell sandbox, which means that in order for me to access them, I need to tell my provisioning server to basically pull images from the Tinkerbell address / name of image, because this is the web root. And the workflows actually are very simplistic. So if we look at the ESXi workflow, I'll make that a little bit bigger. We can see here that there's not really a great deal to it. There's only 2 actions that we actually need. One is to use the image to disk action, which will stream that image from my Tinkerbell server and write that directly to a NVMe drive inside my NUC that I use for testing. And then finally use the reboot action, which will do a reboot of the in-memory operating system, which will then boot from disk. So that's really simplistic. Yeah. For things like Debian, there is one in here somewhere. Yeah. We can effectively do the same sort of thing, but because their kernels support kexec, we can kexec directly into the new operating system once we've provisioned. So effectively, this will provision in around 40 seconds. And that's not just provision the operating system, that's actually boots into the newly provisioned operating system as well.
Wow.
So I can do a demonstration of that shortly. So does anybody else have any other questions around Crocodile?
Hey, Dan, I had a question.
Sure.
So what is the idea that the format of the default cloud images isn't usable with Tinkerbell or with the disk streamer? Is that the main driver to changing the format here?
The main driver, one is things like Windows images. Two, QCOW we can't stream. The reason we can't stream QCOW is that it's not a stream of data. It requires a number of table lookups to find clusters of data. So we wouldn't be able to do that over. We wouldn't be able to do that well over a network, because as we try and access bytes, we need to relook at these tables in the QCOW file system and find those blocks and then pull them. So we convert from QCOW to raw, so that we basically have all of the bytes in line, and we can basically then just read them from somewhere and write them directly to disk without having to do address lookups and things like that.
Oh, okay, that makes sense. Thanks.
And one thing that we actually do find as well is that we can do a QEMU image convert from QCOW to raw, and then if we compress that with either gzip or bzip2 or anything like that, the images tend to be actually much smaller than a QCOW image would be as well. So we can look at different compression algorithms that allow streaming compressed data, which will probably allow us to deploy even faster.
That makes sense. So if somebody wanted to add, just because you brought it up, like WordPress, for example, that would be, they would do it in the actions, right? So it'd be another action right here. So you do your image to disk, then you would install whatever you wanted to, like MySQL or something, right? And then you reboot.
Yeah. So like for Ubuntu, we have an action called cexec, which is chroot exec, which effectively that action allows us to take a newly deployed operating system, chroot inside it. So we could do things like apt-get updates, apt-get MySQL and WordPress and all of that. We can chain all of those together, and then we can exit, and then we can kexec directly into that environment and actually run inside that environment. For things like Windows, then they would probably need to fork. They could either change the raw, they could either change the base image itself. So they could add in a bunch of Packer actions that will build Windows 2016, and then a bunch of post-install actions that will install additional Windows things, and then be based off of that raw image. Alternatively, they could provision, I think I have a Windows image in here. Yeah, I mean, it's not very exciting. It basically streams it. They would do something like this to reboot, and then possibly use some of that Ansible for those post-installation steps.
Right. That makes sense.
Following
Cool.
up on that, though.
Oh yeah,
quick
sure.
question. So as of today, if someone wanted to, like, as you said, do additional actions on an image, they would have to sort of rebuild the whole thing. Is there a thought to making it easy to build on top of an existing image? So this Debian image that you've built, is there a way to like take that Debian image and then like have Packer take that as a base image and do a few additional actions and then turn that into a new image?
Yes. So there's kind of a number of different ways we can approach this. You could either do it in Packer, or with Ubuntu operating systems, it's easy for us to do manipulation as actions. A good example of this, and I don't know if I'll be able to find it or not, is some of the work that has been done by Jason de Tiberius. I can't find it. He's using, let's see if I can quickly find it, sorry.
Maybe while you're looking, can I quickly clarify? So yeah. There's a trade-off between doing something at an action time, where, for example, my thought was if I needed to install a relatively large package to the image, then, which if I'm going to effectively double the size of the image, for example, I could do that once at image build time and reduce the computation needed to deploy it, and they would all deploy really fast. Or I could do it at action time, and each machine would then be doing those actions. Yeah. So I'm asking about I want to build a bigger image to reduce computation at deploy time.
Sure. And then, yeah, I mean, that's entirely possible. If you were to do that, then at the moment, I would recommend forking Crocodile and adding the packages that you want. As mentioned, my plan really is for the repo that is inside Tinkerbell to basically be as vanilla as possible. Because I really don't want us to be in a position where we're trying to support everybody's random whim of random package that they want to try and install inside Ubuntu and things like that.
Yeah, my thought was it would be, I guess there's two approaches in terms of if I wanted to build on top of an approved official operating system image. So if the Tinkerbell project provides an official image for some operating system and I want to build on top of that, either I would have to do a rebuild of it myself and then add my additional actions. I was saying, is there a way to like pull down the official image, the current latest official image for a particular operating system, do my actions locally, and then deploy it to my infrastructure? I think both are acceptable. And it sounds like you're leaning towards you should just use the existing code to rebuild it yourself.
Yes, I mean it's easier using the way that we've set up in Crocodile to add things to it. All of the Packer builds have like post-install tasks, which you can add in a bunch of additional steps, scripts that run, or Ansible playbooks to run against an image before it is kind of finalized. We will probably need to write a lot of documentation around that. And at the moment, because I've been learning Packer as I go as well, so a lot of the Packer manifests are a bit messy. I mean, they work just about, but they need like some proper revisions and tidying up and things like that. But once we've kind of cleaned them all up, we can kind of make it obvious where if an end user wants to take Alma or Ubuntu or whatever, in this section is where you would add your next steps, and that's where you will build the vanilla image plus the additional steps that you've actually asked for.
Thanks.
Yeah, that part seems like the sweet spot to user experience, right? Being able to make the ability to add your own stuff nice and seamless, that would be really advantageous in my opinion.
Mm-hmm.
I have a little bit of an exotic idea, maybe. Is it possible to run? Is it possible to run the build as an action? So like Crocodile as an action. So you spin up one of your bare metal servers, build the images, and then ship them to the Tinkerbell stack and like do it as a one-off thing. Or you could also like schedule it. The workflow.
So, I mean, that would be quite crazy, but it would be entirely possible. So, for instance, I mean, the Crocodile build thing is a Docker container. So you could actually have that as an action. So you could build on the fly and then write that directly to the disk itself. If you really wanted to, you would effectively boot a piece of bare metal. It would build its own operating system and write that to disk on the fly.
I'm more thinking of like if you go with this whole like on-demand provisioning, and then I think it would be amazing if you could just run a workflow to build all the images you want and then spinning it down again. And while you run it to build these things, you just ship them then to the web root, and then you're done with that. Like, because it's basically like a batch job to do these image builds, maybe like once a day, or whenever you have a CVE or whatever.
Yeah, I mean, I don't think it'd be a very often occurrence that you'd be building OS images. Only really when kind of new releases come out. In most cases, you would take one of these images and then do things like an apt-get update and get all of the latest updates anyway. So it really is down to how you kind of want to make use of them, I suppose.
I don't think that idea is exotic at all, right? Because ideally, you would put that in some sort of a build environment that it's reproducible, right? You don't want to be building production images on people's laptops, right? You want to be building them on environments that are consistent and reproducible, right? So using the Tinkerbell stack to do this, I think is actually a great way to do it.
I mean, yeah, I mean, a lot of people can use Packer and things like that in their kind of CI/CD pipelines. So, they'll get a new ISO, or they will point to a new repo, click go, and Packer will just kind of produce you a new golden image at the end of the day. You could, here's a new workflow against my builder machine, it will run the actions as necessary, and you get a new operating system out of it at the end as well. But not too dissimilar, I suppose. Cool.
Interesting.
Excellent. So yeah, that's Crocodile. We have, oh, sorry, there's another question.
Yeah, so you did mention about building images in a web root. So is there a possible, or is it, I'm not sure because I'm new to this. It might sound silly, but I was thinking that you can publish the Docker file as a template, right? Then they can use it as a, they can build their image with the app in it rather than building for them.
So, I mean, all of this, everything that's in the Crocodile repo is effectively a combination of Docker files, Packer manifests, and a bit of Bash that tidies it all together. So, I mean, anybody can take those manifests and do what they like with them. I don't really have a plan for us to host OS images. It's more a case of, here's the tools for you to go and build them yourself. As mentioned, it will get all of the ISOs from public sites and build them for you. So it's reproducible builds just where you would like. And here's all of the code that does that for you.
Okay. Yeah, thanks.
That's a really useful clarification. Thank you.
Cool. Okay. Yes, that's Crocodile. As Marky asked, FreeBSD, we can add that onto the roadmap for it. There's also asks for Arch, NetBSD, OpenBSD, and we'll probably add in some additional operating systems just as people ask for them. But they should be relatively straightforward to kind of do that. Excellent. So next is, I'm gonna have to share my entire desktop, I think, for this. Okay, let's move that. So one of the things that we're looking at doing is improving the output from Hook. So there's a couple of changes that we'd like to make to Hook. Let me quickly kick this off so you can see what I'm actually talking about. So I'm just going to delete this workflow. And right, where's Windows? ODF. Okay, so I'm going to redeploy Windows on this NUC just so I can kind of quickly show what the plans actually is. So this is KVM on my NUC. It will reset in a second. There we go. So one of the things that we've looked at adding is a slightly different provisioning. Okay, a slightly different provisioning option inside Tinkerbell. Hook is built upon Linux Kit, which effectively allows us a quick way of putting together a bunch of containers into an operating system. And those containers that we add in there are things like Tinkerworker, etc. It works in exactly the same way as OC. It's just a little bit quicker. So one of the things that we are looking at doing is removing a load of superfluous modules that aren't needed. You can see we're paused here. What is happening is that we are decompressing the init ramfs into memory. That takes 12 seconds. It's now running from the init ramfs. It's now started Tinkerworker, and we can see these kernel messages. So in the square brackets with the amount of seconds and milliseconds that have gone past, we can see a load of D-message output and things like that. What we can't see is what's actually happening inside the containers. So what we are looking at doing, as mentioned, reducing the amount of superfluous modules that come with Hook, making the init ramfs much smaller, meaning it will start a lot quicker, and two, modifying the way that Linux Kit runs so that the containers, the actions that run will output text and output information to the console, dev console. At the moment, the only way to kind of see what's going on is to use container D's pretty hard to use. So I don't remember. It's very hard to remember how to do this. But effectively to use container D's CLI, which should allow me docker ps -a. There we go. So yeah, we can kind of see what's going on, but we need to do it from the command line and we can't actually see what's going on. So it would be nice to yeah, be able to actually have this output written to dev console whilst it's actually taking place, making it easier for people to debug and for people to actually see what's actually happening inside the running action. So I've started looking at that now to see what would actually be required. It's going to require some fiddling around with the Linux kit modules, but it should make it a little bit more of a pleasant experience when using actions with hook. So making it smaller so it runs faster and making it more verbose whilst it's actually running. So those are some of the upcoming things that we're looking at doing with hook. Does anybody have any questions around that? I think it's all relatively self-explanatory. All right, cool. And finally is Jason's not here, but one other thing is Cluster API Tinkerbell. That has been migrated now to be using a lot more. It's now using hook, and it's also using a load of the new actions so that it can actually make use of Cluster API upstream images. So that is now much quicker to deploy Kubernetes on bare metal. The final thing that I wanted to talk about was we've finally gotten the documentation on Tinkerbell all updated now. So there's all of the documentation around actions, action hub, etc. And we have all of this additional documentation around getting various other different operating systems deployed as well. So this documentation here typically talks about using upstream images. We probably need to add in some additional documentation around how you use Crocodile to generate your own images moving forward. So that's some additional thing we're looking at adding in the near future. That's it from my update. Does anybody have any other questions around any of that? Thank you very much, Mara, for all of your amazing work with the documentation as well. All right. I'll leave Windows to boot in the background. That's everything for me. Thank you very much, everyone.
Thank you, Dan. I just have one thing that I added to the agenda list, and that is we did attempt to make an Americas meeting. We didn't have a lot of luck with that because calendars and time zones are difficult. One of the things that I wanted to propose to the community is that we, in having this one meeting, if everybody would be open to the idea of moving it 1 hour later. So if you're on the West Coast, that would be 8 a.m. instead of 7 a.m.
Plus one from me. I don't know how you want to go about doing that.
Yeah, so what I'll do is I'll send an email to the mailing list.
Okay.
Let it go for a week or so, and then if there's nothing, I'll work with you, Dan and Gianluca, and Jason also, to get the calendar updated and move the time, and then I'll send out another email letting everyone know that that has in fact been done.
Excellent.
Fantastic. That was it for me. All
right. Well, thank you very much, everyone, for joining. I think I would not be surprised. I think that 1 hour later we'll go through, and we can hopefully then settle finally on a meeting slot that is a little bit better for everybody. Yeah. thank you very much, everybody, for all of your work, your submissions, your issues, PRs. If anybody has any suggestions around additional operating systems or any other suggestions, proposals, etc., we would love to see those. And yeah, thank you very much, everybody.
Thank you,
Thank you very
everybody.
much.
Thank you, and enjoy the rest of your day.
See y'all.
Cheers, all.
You too. Bye.
Bye.